Hi everyone, we're going to sketch the graph of this polynomial f of x, and first of all we're going to determine the degree. The degree is based off how many x's you have, or your lead part. So if you put this in standard form, these three factors, you'd have x to the first, x to the first, x to the first. So merely when you're finding the degree, when it's the polynomials are already expanded, is you just add these up. So you have 1 plus 1 plus 1. So our degree is n equals 3, because there's 3 of them. When we graph this, we have a maximum number of turning points. So that would be 3 minus 1, which equals 2. So at most we have 2 turning points. The end behavior we'll discuss in the next slide. The y-intercept is when x is 0. So you just plug in f of 0 here. And if you plug in 0 here, you're going to get negative 1. Plug 0 here, you're going to get 4. You plug in 0 here, you're going to get negative 3. When you multiply that through, you're going to get 12. So your y-intercept is 0, 12. And your zeros are when y is 0. So if this is 0, your intercepts will be 1 here, negative 4 here, and 3 here, because this will make this factor 0 and so forth. So that's just going to be 1, 0, negative 4, 0, and 3, 0. Those are your zeros, are your x-intercepts. And this part, we're going to look at the graph by determining those intervals where y is negative and where y is positive. We'll look at the graph. So first of all, let's determine the end behavior. And that our degree is n, and also this is positive right here. So let's look. When we look at this, our n is 3, which is an odd number, and it's positive. So we're right here. That means our graph has the characteristic of the cubic function here. And this is positive. Quadrant 1 is positive. Quadrant 3 is negative. So that's what this means. As x goes to positive infinity, so does y. And the same thing for quadrant 3. When x tends to go negative here, so does y. Okay. So basically, this are going to be our starting and ending point. We're going to be starting in quadrant 3 and ending in quadrant 1 as we graph from left to right. So basically, our zeros were 1, negative 4, 1, 2, 3, 4. These are your x-intercepts. And 3. 1, 2, 3. Also, they're all going to cross because they had degree 1. They had an even number of degrees. And our y-intercept was 12. So I'm going to make this a 12. It's not drawn to scale. And we're just going to sketch it. So that since our equation y equals x minus 1, x plus 4 times x minus 3, since these are all 1s here, that means it crosses the graph. What we're not going to do is max a minimum here. We're just going to sketch it. So basically, we start in quadrant 3. So you start in here, go up to the y-intercept, come back down through 1. Now the part we don't know is how long and stuff it's going to be in here. You can find out by plugging in points, but for the just sketching the graph, we're just going to estimate. And then we ended in quadrant 1. So there's your end behavior here. We started in quadrant 3 and ended in quadrant 1. Now the only thing else we have to do is determine where y is negative. So here is where y is 0. So y is negative from negative infinity to negative 4. Y is also negative right in here, this part of the curve, which is in between 1 and 1, 2, 3. I think this was supposed to be 3, yeah. I should have graphed this through 3. So let me graph it through 3. So it's something like that. All right. So 1, comma 3. So this is where our y is negative, or f of x is negative. Now where our y is positive is right through here. This is part of your graph where it's positive. So f of x is positive, or y is positive from negative 4 to 1 and from 3 to infinity. And that's it. Have a nice day. Bye-bye.